In this video, we're going to learn about electron configuration. In the last video, we learned about Bohr's model of the atom, which showed that the electrons exist within specific energy levels within the atom. But those energy levels have a lot more detail than just being a circular orbit. They contain orbitals, or little homes for electrons. So we're going to take a look at that today. So on the first energy level, there's not a lot of room. It's really small. We have room for only 2 electrons that are housed in what we call an s subshell, which contains just one s orbital. The s orbital is spherical in shape, holds up to 2 electrons. So in the first row of the periodic table, we only have 2 elements because we can only hold up those 2 electrons. So hydrogen has 1 electron. It's going to exist in lowest possible energy state, which is in the first energy level's s orbital. Helium would have a second electron, and that second electron has to have an opposite spin, which helps reduce repulsion and minimize the potential energy of the system. But once that's full, there's no more room in the first shell. So if an atom has more than 2 electrons, it's going to have to start filling a higher energy level. So we'll move on to the second energy level, where now we have our first energy level filled with 2 electrons, and then we have 1 in the second energy level's s orbital. So we can see here that in the red right here, you see those buried inner electrons, 1s. In the second energy level, we have an electron in the 2s. Then beryllium would have a second one, again, opposite spin to reduce repulsion, minimize potential energy. And then after that fills up, there's no more room in that s subshell because it can only hold 2. Then we move on to what we call a p subshell. So a p subshell is going to consist of 3 orbitals, each capable of holding 2 electrons. And as we add more electrons, we're going to fill those out. So you can see here that boron has 5 electrons, 2 in the 1s, 2 in the 2s, and then it has 1 in the second energy level p subshell. And then carbon's going to have 1 more than that. Notice we're putting 1 electron in each orbital of equal energy before we put 2 in any. That's what we call Hund's rule. Then, once you have 1 electron in each orbital, now we're going to have to start pairing them up. So this p subshell can hold up to a total of 10 electrons. Notice we've reached the noble gas column on the periodic table, or noble gas group, which has a full outer shell. Once we get past that, we're going to have to start a new energy level. So then we go back over to our alkali metals. We have sodium with 11 electrons. Now it's going into the third energy level, which contains an s, a p, and a d subshell. So 1 electron in the third energy level is s subshell for our sodium. Magnesium would have a second. Now you can see that we jump again across the periodic table. The third energy level is p subshell, and we keep adding electrons as needed until we complete that third energy level's p subshell. Now we get what we call an energy level overlap. So we've reached a noble gas, the next electron is going to have to go in a higher energy level, even though we haven't filled out the third energy level's d subshell. And that's because if you look here, this is in order of increasing potential energy. The fourth energy level's s subshell is actually lower in potential energy than the third energy level's d subshell. So potassium, which has 19 electrons, will have 1 electron go in the fourth energy level's f subshell before we get over here to the 3d. But then calcium has 1 more than that. Now that's full. Now we move on to the 3d subshell, and we fill that out just the same way. So bottom line is the first energy level, just an s subshell. Second energy level, s and p subshell can hold up to 10 electrons. Third energy level, you have an s, a p, and a d subshell. So technically that can hold up to 18 electrons, but we're going to have an overlap that happens where the fourth energy level's s subshell fills first. Anyway, now we continue filling our d subshell until we get to zinc. Once we get to that point, we're now re-entering the p block of the periodic table. So in the fourth energy level is p subshell. So then we go in there. Right? And this continues. Once we get again to a noble gas, then we have to start a new row. And this will happen over and over until we get to the 6th energy level. Once we get to the 6th row on the periodic table, now we're going to have 6s fill up, but then after that, we're actually going to drop down to the 4th energy level's f subshell, which can hold up to 14 electrons, and then that will fill up until we get to the fifth energy level is D subshell, which starts here with lutetium, and then we continue filling that until we get back up to the 6p subshell. So these are how the electrons are arranged in atoms. They have homes that are more specific than just spherical orbits. Thank you.